Good morning, everyone. Welcome back to. I actually don't know how many videos I've done now. The next video. I already have my to-do list up. If you caught the last one, you'll know that we did a bit of refactoring in the renderer and screwed it up, and I'd spend a while debugging it. That's all now working. So if I just, for catch people up sake, I have it drawing some stuff. I have it doing a gross bright pink clear, so it's really obvious what stuff is background. If it's black, like we're drawing black, this pink is something we're not really drawing anywhere. It's currently just using the sprites from Flectress and this circle, which is easy enough. I've added this gradient sprite as well. Now it's easy to add sprites. That was kind of the entire point of that change. And I was like, I think this would have made it easier to debug what we were seeing. Because the issue we were seeing was I had my texture ordinates being done wrong. So if that quad there is the texture, I need to set the base position down here and it samples up and right. Whereas I was setting it here and sampling up and right, which, because of the way this works, then just it stretches the value on the edge upwards. You get vertical bands. And because all I could draw was stuff that was kind of the same from left to right, I don't know. It didn't click to me, whereas I think this would have helped. So here, it goes from red to green, and it's slightly different, like in each direction, right? It gives it a kind of a diagonal directionality. Means, for example, if I go put that same bug back in, where it be main, Odin, its base position being the top left, not the bottom left. And we do that again, we get this very clear vertical thing, right? I think it's easier to see that what's happening here is we're getting that top value stretched upwards. So, as we'll see if that's true. I have the asset now, which makes it easier to just drop in quickly. But that's not what we're doing today. Today, I am going to address a to-do that we left last time. And depending how that goes, I might make a start on this resizing behavior. So let's crack on. Just search for my to-dos. This is the thing I'm upset about. So bear in mind, the point of that change is I would like to make it so you just pass in this list of textures and we make it as easy as possible, or easy maybe even the wrong word. It's as like automatic and unerror prone as possible to add a new texture. So what I was doing previously, I had fonts and sprites, and I just said, you know, the renderer has a font texture image and a font texture image view and a font blah blah blah, and you just had a group. I think there's 4 fields for each texture you wanted to add. We could have just continued doing that forever, but it's painful. It means we can't do anything programmatically. So I think for our nicer font handling, we might end up generating a bunch of these at runtime, which is something I've not thought about at all. Which is all to say that what I wanted to have was just like these things as lists, right? The lists are a known size, so there's no memory allocations to worry about, but this is all just done once on initialization, so we in future probably can allocate memory here and it'll be a worry. But I'm still slightly miffed that the way this now works is when I wanted to add, say, this gradient, I add the gradient there. I need to then remember to also get the gradient texture index correct. And if I were to make a change that flips the order of 2 of these, I have to remember to come back in here and change this value, or I'll have a bug that I don't know if that'd be easy to debug. It's probably easy at this point, but if the program grows and we end up with a lot of these, it might become non-trivial. And yeah, so I think what I was thinking is it might be better to instead have a map. So what I would have is I pull these out into constants. I make a map I don't know if I can get the keys of a map out in a reliable order, so that's worth checking. What I was going to say is I use a map. I put these all into the map with the name as the key, the value as its index, and if I can get the keys as like a slice in a reliable order, then that would work for me. But now I'm unsure if that's the case. Let's have a look. Odin. Oh, like reference. Their reference doc tends to have these kind of basic things in. I'm after. Range-based for loop is not what I want. Some map. There must be a map section, right? Iterating maps. Maps. Right. So maps keys to values. The 0 value of a map is nil. Nil has no keys. You have to use make and delete. Insert or update, retrieve an element, remove an element. Modifying existing map slots needs to be done in 2 steps. However, assigning to a struct field is prohibited. Test struct x int y int map of string to test. Bob is that. Chloe is that. Oh. Value okay. References map Bob. If okay. It value equal to 22, which has updated. X is now 0. Modifying existing map slots needs to be done in 2 steps, so you have to get it and then do it. Okay, so that's okay. Do that as well. That's okay. So I guess you do this one if you want to be sure Bob exists before you set the value. You do this one if you don't care, and you'll insert if it's not there, and you update if it is there. But it's saying you can't just update a struct field. That's interesting. I wonder what that's about. The built-in map also supports all the standard container calls. So I can iterate over the keys. I think that's what I saw earlier. Don't know though. I don't see anything about the order of them. Right, let's see. Where was that iterating stuff? Certain built-in types could be iterated over some map or key in some map or key value in some map. Iterated values are copies and cannot be written to. When iterating a string, you can iterate arrays. Map values can be iterated by reference, but their keys cannot, since map keys are immutable. It's not possible to iterate a string by reference. I mean, should we just try it? Let's see. Odin map key iteration order, maybe? Every Odin feature. That's just some guy. Null map has no keys. This is an old thing. This looks like it's the sort of proto version of that other thing, isn't it? From old Gingerbill himself. If maps are not ordered, why does it display? It's all in Go now. What does Go do? What determines the iteration order of keys? Error runtime uses a common thing. Implemented in C. The only implementation differences between that and that are hash function, equivalence function, and copy function. Unlike some C++ maps, they aren't fully specialized for integers and for strings. Iteration order is independent from insertion order as long as there are no key collisions. If there are collisions, iteration order is affected by insertion order. That's not even the same language, so I don't know. I think it's likely that these things aren't I don't know where you would look to see that in the Odin source. So that's not like a package, right? That's sort of built-in syntax. Okay, so let's assume that the iteration order for a map is not guaranteed. What do we do? So let's make this a little section here. Instead of texture paths, we do font texture path is assets font PNG, sprite texture path. So I think step one is we just pull these out like this. Sprite texture path is that. Yellow texture path is assets yellow.png and gradient assets gradient. All right, and then we take all of that, and instead of this, you go font texture path, sprite texture path, yellow texture path, and gradient texture path. All right, so far, there is no real change. Oops. So that should look exactly the same. And if I were to swap two of these around, it should break. Or at least it should look really wonky, right? So let's come in here, do all of that, but you and you swap round. Our indices are now wrong. It looks wrong. So that's all working as expected. And if this is working properly, I should be able to do that at the end. Can I... How do you do this? Can I say in here... texture index map. A map from string to int. How you do that? Let's look. Maps. You're not allowed to just do that there because it requires a context. It's fair enough, if slightly annoying. So, blows up horribly at runtime. Should that live in renderer? Quite possibly, right? As in, should it be a field on renderer? I guess I'm more accurate to what I'm saying. Yeah, so these are the things that are currently broken. I could use an enum. But enums, I think, by default just count, don't they? They go 0, 1, 2, 3, 4 in order. Enumerations. Is there a way to just be like, and then iterate over every value in my enum? My two type values consist of the ones specified. The values are ordered. The following holds. It's an enumerated array. Allow the use of an enum to be used as indices to a fixed array. Extend the direction enum to add direction vectors. Direction vectors. Ah. That might be what we want. So I could then have an enum. In this case, it would be like font, sprite, yellow, and gradient. And then texture paths be this enumerated array with the actual string values. Does that help? I don't know. We'll try it. Was partial and sparse can be used to initialize an enumerated can be used to initialize it, which does not have contiguous values. That's not us. All right, let's see. So what if we have texture enum, go font, sprite, yellow, and gradient. The syntax, it is texture C string. Like that. No. They're complaining. Enumerated array literals must only have these. So you'd have to do dot font equals that. Dot sprite equals that. Dot yellow equals that. And dot gradient equals that. That should complain. If I miss one, it complains. What if they're out of order? So I'm hoping the order is set by the enum value, right? As opposed to... I might want to just inline these then, because I think this is the third way we're going to be accessing them. That's now sprite. And that one is now yellow. And that one now gradient. We sack all of that off. That breaks. Right. Because you now would have to be... just... Oh, how would we do this? Texture dot sprite. That's still angry. Needs to just be a number. It is just a number though. Can I tell this? You can tell enums what their backing data type is, can't you? Yeah, enum. So I can say there enum i32. Does that then work? Oh. I get the value of the enum. Just cast it. Right, and then these aren't defined. So we'd have to say cast i32 texture dot sprite. Texture dot font. Your cast i32 texture dot yellow. Your cast i32 texture dot gradient. Blows up. Failed to load texture image. It's not called sprite, is it? Let me go back into renderer. Let's get rid of a bunch of this. I think it's called sprite sheet, is it? Okay. Something's gone skewy. Yellow and sprite are the wrong way around. Your yellow, your sprite sheet. Alright. And the interesting part is if I switch these around, nothing breaks. If I switch these around, nothing breaks. I think that's better. And obviously, if I delete one of these, then it will blow up immediately. If I add something, then it will refuse to build because it's not handled in here. That feels much neater, doesn't it? How cool. And so I think the order is determined by the order they appear in here. We can even check that. So we've now built it. Can I cd into game? We'll run render doc. And we will launch main.bin from game2. Capture a frame. Look at our inputs on the draw, not on the present. So what do we have? We have sprite, then yellow. We only have sprite and yellow. Interesting. Is this naughtiness in my fragment shader? It is. It thinks there's only 2 of these. Bugger. I just make you a pointer? I expected star, expecting. I don't know how these types work. Piss. Right, that number should be the same as the number sprites is the issue. It turns out it doesn't break anything, but that's probably device specific, if I had to guess. Sorry, come in here. Do the capture. In here, get the draw. Yeah, as you can see there. What can we see? All right, go sprite, yellow, font gradient. Alright, we'll worry about that later. What I might do. See, this feels like an argument max. I feel like in the last video I was saying it might be worth having something somewhere that's like this is the maximum number of text samplers or maximum number of texture things. Okay, hang on. Getting carried away. Let's that's going to annoy me. I'm going to make that 100. And I'm going to go to renderer. I'm going to add a assert at this point that says texture assets count less than or equal to 100 with a comment to say fragment shader hard codes maximum number of texture samplers it can handle. If this fails, take that too. If this fails and we bump this number to update the fragment shader too. Quite angry. Only declarations allowed at this. Oh, I can't just statically assert there. Can I like compile time assert? Odin, compile time assert. Probably a bug. When I run this, or even this, it generates the expected assert. Hash assert. What is hash assert? That exactly what I'm after. I think hash tends to mean like compiler directive. Beautiful. So it is a hash assert. This thing. Let me just check that that blows up. Compile time assertion that failed. Did you just know that? Interesting. Cool. Didn't know we're less clever. All right, what was I doing? This goes yellow, then sprite. No, is this what I'm looking at? That determines the order. So sprite, yellow, font, gradient. Let me look in here. Sprite, yellow, font, gradient. If I kill that, and we instead go sprite, font, gradient, yellow, build. We run render doc. We capture the thingy, capture a random frame, and we look at our draw. We can see sprite, font, gradient, yellow. Yeah, works exactly how you think. Sprite, font, gradient, yellow, and it doesn't matter what the order in here is. Although it is pretty weird to not have them the same, so I'm going to make them the same. Cool, I like that. That seems way better. Let's get rid of you. Did I delete the to-do? Can we infer these? We can. Cool. That feels like a neat little trick. I modified. That's modified. I wonder if texture to index rock that takes a texture, turns an I32 that just does cast I32 texture. Like that. And then, sorry, this bit in yeah, texture to index. What's your problem? Ah. If a resource variable is declared in a shader as an array, corresponding descriptor set in layout match the count. That's really awkward to line up, isn't it? I'm not sure how we do that more neatly. I don't really want to make the descriptor layout have all those empty spaces. That just seems pointless. What is it? That should be being precious. Okay, let's see. Missed one. Validation error. Back into renderer. It's slightly wasteful of space, but again, the things we're doing are so simple, I'm not sure it matters too much. So can I say here, texture assets count max will be 100. Insert texture assets count max. Then we go look for create graphics pipelines. Your create info points to stages, which is defined up here. It's the fragment stage. So the fragment stage uses a descriptor. It's not defined there though. With descriptor count, let's go find that descriptor. Descriptor set. Okay, descriptor count down here. So there's our thingy layout, texture combined, samplers binding, and we're only telling it how many there actually are. Can I make that count max? Oh, bugger. How are you meant to do it, is it? You just keep holding control. That should blow up because it won't let us allocate it. Trying to allocate 100 from a pool size of less than 100. So we have to come back and say descriptor count. Go back. Make you a max. Now we're angry everywhere else. Is this the descriptor? EK command draw indexed. This descriptor is being used in draw but has never been set up. EK update descriptors. Index 4, we jump up. Index 4, it will be the 5th one, so the first one's never actually used. That is true. So that's probably not the right way to do it. All right, let's put that back. Let's help us back to this state here. I mean, this feels like it's the sort of thing that wants to be like a meta program, doesn't it? Where that value gets inserted. I don't know how to do that easily, and I don't want to get distracted because I don't think it matters too much. Can I say here fragment shader expected texture count is currently 4. Insert these to equal. Fragment shader expected texture count. Fragment shader hardcode's maximum number or expected number of texture samplers it can handle. If this fails, we bump this number. So if this fails, because we've the number of texture assets, we need to remember to update that too. So imagine that's 2 because that's what it is in the thing. It won't compile now. Go in here, we make that 4, and it will compile now. Good. And we will remember to go and do what it says. We make that say 4 instead of 100. I think that's as good as we can do without writing a program to grab that value after compiling. Okay. Well, if nothing else, it'll act as a reminder, right? If I remove one of these, like that, the assert blows up. If I ignore the assert, other stuff blows up because of reasons, but we don't care. I think that's a sensible thing to do. It'll remind us to do it. It's still manual, which kind of sucks. Better, I think. So what we've got in here, we've got a more hard-codey manual thing to be doing. I think we've achieved that. So that's good news. So let's stage all of that, make all of that. What do I want to say? Refactor, make texture, asset handling less error prone. Alrighty. Just keep an eye on the time. I'm not sure how long I've got now, so what I might do, I might snip this one here. Call that one video. We have kind of achieved a distinct thing, right? And we'll do resizing behavior in another video. Either imminently, if I have got time today, or possibly another day. Right. That was fun. I enjoyed that. I will catch you on the next one. See you later.